When you read this example, you might recognize it because it's identical to one we did earlier in the unit. We just did it in degrees. And the reason I spent a fair bit of time reviewing reference angles and angles in standard position and how to solve trig questions in degrees is because now we do those exact same questions. The only thing we change is now our domain is in radians instead of degrees. So the whole process is exactly the same. The only thing different is a calculator setting. Instead of our calculator being in degrees, we do it in radians. So how did we do this question? We've got a point on the terminal side, terminal side of an angle in standard position. So -4, 3. That would be 1, 2, 3, 4 this way, 1, 2, 3 there. There's the point, -4, 3. That point is on the terminal arm of an angle in standard position. So what did we do with this when we dealt with degrees? Well, we drew a triangle back to our nearest x-axis so that we had a reference angle. We know that this side is 4 and this side is 3. And the first thing we wanted to determine when we looked at that is, can we figure out what that reference angle is? And that's just going back to grade 10 trigonometry. You have a triangle. It's a right angle triangle. If I want to find my reference angle, I know my opposite side and I know my adjacent side. So I can set up an equation that tan of my reference angle is opposite over adjacent. And if I wanted to calculate that reference angle, well, I'd go to my calculator and I'd go tan inverse of 3 over 4. Now the difference now is when we go to our calculator to do that, second, tan inverse of 3 over 4, we get a value that looks weird because it's in radians. Our calculator's mode is set in radians, and so now we get a reference angle that is 0.64. And I guess it says to the nearest tenth, but I'll write 0.64. That's our reference angle right now. Now we want to find all possible values of theta between -2 pi and 2 pi. So what does that mean? Well, 0 to 2 pi is once around the circle in the positive direction. That matches up with the green angle. 0 to -2 pi would be once around the direction in the negative side, so the only angle we would have there is this red angle of theta. So we have two possibilities for theta because we're looking for answers once around in the positive direction from 0 to 2 pi and once around in the negative direction from 0 to -2 pi. Now if you were dealing in degrees and you wanted to find theta, well, you would go 180 degrees and minus your reference angle. Now that we're dealing in radians, the process is exactly the same, but instead of doing 180 minus your reference angle, you'll do pi minus your reference angle. Now when doing that in our calculator, I'm going to show you something on your calculator that is helpful. Right above the on button is a store button. If you click the store button, it says, where would you like to store your answer? And so I'm going to just temporarily store it as x and push enter. And now your calculator is remembering anytime you want to use that number, you just have to push x. So if I wanted to do pi minus my reference angle, I can just do pi minus x. Now it's going to be helpful because we're going to want to use that reference angle more than once. It used to be if you just wanted an answer once, some of you probably know where the answer button is on your calculator and have used that. But this X button is going to be nice when you want to use an angle more than once. The other thing about this course is you never round any of your answers until you write your final answer. So that's why I wrote my reference angle as 0.64 with a bunch of dots, because I knew I was going to keep all of my decimal places, and it's only now that I'm writing my angle that I'm going to round to the nearest tenth. So theta is equal to 2.5 radians. To figure out my other angle, my red one, if I was dealing in degrees, I would say halfway around the circle is 180 plus my reference angle, and then whatever answer I get, I'll make it negative because I'm going in the negative direction. So if I'm dealing in radians, I'm going to go pi plus my reference angle, and whatever I get from that, I'm going to make it negative. So in my calculator, again, I'm going to go pi plus my reference angle, which I still have stored as x. I push enter, I get 3.8. And so I know that this angle is negative 3.8 radians. So there's part A. Same idea as we did with degrees. Now our reference angle and our final answers are in radians. We had to use pi instead of 180, but the process is the same. So we want to make sure that we know the process really well in degrees, so when we switch to radians, it's just a little thing that we're changing. Part B, given cotangent is negative 2. Well, if cotangent of theta is negative 2, that means that tan of theta is equal to negative 1 over 2. So here, notice the angle hasn't changed, but my ratio is the reciprocal. And if I'm solving this question between negative 2 pi and 2 pi, if I was solving it in degrees, first of all, I would think of my cast rule, and I would say, if tan is negative, what quadrants would it end up in? It would end in quadrant 2 or quadrant 4. I make my triangles back to my nearest x-axis and label my reference angle on both of those. And since tan is the opposite over the adjacent, I can label and say this side would be 1, this side would be 2. This side would be 1, this side would be 2. I could find the hypotenuse if I wanted to with a squared plus b squared equals c squared, but this question is asking us to find theta from 0 to 2 pi. Well, from 0 to 2 pi and from 0 to negative 2 pi, can you see that you would have one angle in standard position here? And you would have another angle in standard position here. And both of those green angles would be positive. And since we're also looking from 0 to negative 2 pi, again, it's very important to look at what was your original domain. And here it's negative 2 pi to 2 pi. That means we're also going once around in the negative direction. So here's another possibility for theta. And if I go once around in the negative direction and end at that terminal arm, here's another possibility for theta. So to start off with, I use my grade 10 trigonometry. I set up, I know that from that triangle, tan of my reference angle is opposite over adjacent. All positive values, because when we're dealing with an actual triangle, we're dealing with actual lengths. Whenever you're finding a reference angle, you're always using positive values. So to go to our calculator, tan inverse of 1/2. And we get our reference angle to be 0.46. Again, I'm going to store that as x in my calculator so that I can use it for all of my angles. For my green angles, can you see that this one would be pi minus your reference angle? And this one will be 2 pi, 360 minus your reference angle, so it's going to be 2 pi minus your reference angle. If you type those into your calculator with your reference angle, you'll get 2.7 for the first one and 5.8 for the second one. For your red angles, and I'll just finish this up, your first red angle is just going to be negative your reference angle, negative 0.5. And your second one will be 180 plus your reference angle, so pi plus your reference angle, negative 3.6. 13 and 14 for practice.